Hey guys, this is the first video of calculus on my blackboard. On this class, I'm going to teach you guys limits. So, what is a limit? If I would define this in real life, I'd say, for example, I'm a handball player. I start training 2 p.m. and the time I have incurred is until 10 p.m. I start training non-stop, and I can only reach 4 hours of training. I didn't got to the 10 p.m. limit that I had, but I got to limit of myself. This is a brief explanation of limit in real life. Something that you can achieve and don't go forward. But in math, limit is a little bit different. In math, limit is when we define x is approaching to a value, and when x approaches this value, what value does the function get to? What values the function gets to? Like, for example, y. To start this class, I would like to tell you guys the notation. Notation is something pretty important when you're looking in maths, because if you write it wrong, everything is going to be wrong, so it's pretty important. In this case, the notation of limits is LIM, that stands for the 3 beginning letters of limits, of x, that is the x value. Now we write an arrow here, that means tends to, then n, that is the number that we want the x to tend to, of f of x, that is the function. This is the notation of limits in math. For example, limit of x tending to be 7 of f of x, or limit of x tending to be positive infinity of f of x. And now, I got to a point that I want to talk with you guys. What is positive infinity? And why do I write like this with positive sign in front of it? When we think about about infinity, we almost every time think about a pretty big number. But in math, we also have negative infinity. That is a pretty small number. Okay? This is why it is pretty important to write positive and negative infinity. If you want, you can only write infinity when you're talking about positive infinity. Don't mention the plus sign before it. Okay, so let's get to the first example. Here, there is the imaginary function f of x. On this imaginary function, x tends to be y, tends to get to y, and also tends to get to x, the x-axis. But what does tends mean? It's the same thing as the word tends in English means. It wants to be, but it's not. It tries to be. Okay? Let's start with this part of the function over here. The one that tends to be the line x here. If you take a closer look to this part of the function, we can see that the orange line is getting pretty close to the x-axis when x is getting bigger. So how can I write that? As a limit, I'm going to write limit, that is lim, of x tending to b if the x is going to this way, it's getting bigger. So it's tending to be plus infinity, positive infinity, of f of x. It's equals to. I'm going to say the answer afterwards. Now, let's talk about this part over here, where the orange line tends to get to y. Here, I'm going to write limit of x tending to be a number pretty near 0. It is getting closer to this part, near 0. So x tending to be 0 of f of x, it's equals to. Okay, before showing you guys the answer, I would like to talk a little bit more about these lines that f of x wants to be, but is not. These lines are called horizontal asymptotes and vertical asymptotes. The names are pretty self-explanatory. A horizontal asymptote is a line that x wants to be, but is never going to be, that is horizontal. And a vertical asymptote is a line that f of x wants to be, but is never going to be, and it is vertical. On this case, the horizontal asymptote is the one in green here, and the vertical is the one in pink. Okay, going back to the answers. If x is getting pretty big, that is positive infinity, which value does f of x going to be? If the orange line is getting pretty close to x, to the x-axis, y is getting smaller and smaller and smaller. So when x is infinitely big, f of x is going to be equal to 0. And now, looking when x is tending to be 0, so it's getting pretty close to the y-axis, we can see the slope is almost vertical. And this is that the number is pretty big. So when x is getting closer to 0, the y, that is the answer of f of x, is getting pretty big. And that is plus infinity. Okay. But why those answers here are only the limits of the function, not actually the answer? Sometimes the answer of the limit can be the answer of the function. But in this case, it is not, because, as I mentioned before, f of x is never going to touch the x-axis. So it's impossible to be 0. Basically, it wants to be 0, but it's never going to be. Something that I want to add, it's something pretty important. I think it is pretty important, is how can I write this on the calculator? So basically, we can write in two different ways. If you have a limit of x tending to be a pretty big number, that is positive infinity, we can write on the calculator to substitute on the function. For example, x plus 3 divided by 2, we can write like 10,000 plus 3 divided by 2. Or an even bigger number, 1,100,000. And if you have limit of x tending to be a negative number, for example, of the function x minus plus 3 divided by 2, we can write negative 10,000 or 1,000,000 or 100,000 plus 3 divided by 2. The answer is going to be the limit. So guys, this is the video, and if you liked, leave a like, leave a comment, and subscribe to my channel. The slide of this class is going to be at the blog and the Discord channel. If you guys want, you guys can go take a look at there. Thank you for watching, and see you on the next one.